Hi Bobby.
Hi Aniruddhan. So you have to play with bipolar junction transistors.
Bipolar junction transistors or the BJT.
BJT.
So maybe just as a quick reminder, this is the symbol for the BJT.
Correct.
And this is called the base, collector and emitter.
This is NPN.
NPN. And most of the circuits that we draw will use the NPN.
Correct.
They can also be built with PNP.
Yeah.
We will use NPN because it's easier to understand. I think last class we saw we gave some DC, we used some resistors to
Correct.
build the DC.
Correct.
Found out that gave a DC input, found that there is a DC current through the transistor. We ended up building such a circuit.
Yes.
What shall we do today?
Let's say I want to amplify or something, some signal.
Okay.
That may be difficult or.
Let us see. So let us see what amplification means, right? I think we have seen last in the previous course in electronic systems thinking and circuits. We have seen what an ideal amplifier is.
Correct.
Right?
Correct.
I think we have seen that if you put in a sinusoid, right, which is some Vm sin omega t, and it has some gain A, you will get A times Vm sin omega t.
Okay.
Yes.
Okay.
So this is what we want to build.
Factor of multiplication has to come.
Correct. So we want to build amplifiers. That's what we have been promising the students.
Correct.
Right? We have told them you need transistors, you need electronics for building amplifiers.
So somehow we have to go towards that.
Correct.
So this Vm sin omega or the signal where will I give? Or and somewhere I have to take output also. I have only this
that is
terminal
correct.
device.
See, what we did with the DC was we saw that the current through the device is exponentially related to the base-emitter voltage.
Okay.
So it seems like we should be giving this input to the base-emitter voltage so that some current will flow through the device.
Then shall we give some voltage vary? I mean VBE will give some voltage vary from a very low voltage and see what happens to the VCE or.
That's a good idea. Before we even go to this amplifier,
we need to get some feel about this.
That is true. Let us do that first. What we'll do, we'll choose one simple circuit, no? Like what you said, we'll apply VBE, look at the output. We only have a current, no?
So we have to convert the voltage?
Correct.
Okay.
We will do like what we did last time.
We'll connect a series resistor.
Series resistor.
Okay,
Let us do that. So.
This resistor, okay. I'll get a voltage then. There's a current.
Correct. And
so VCC is the external power.
That is a battery. That is a fixed battery.
Previous circuit also we used, I think.
We used that, correct. And what we will do, we will going to vary this. This is what you are suggesting.
Correct.
Right. And so maybe I'll call this some VI and this is VO.
Okay.
So you said vary VI.
And see how V0 changes.
V0 changes. Good idea. So first I'm going to draw the axis. So let us say this is VO versus VI.
Yeah.
Okay.
Initially VI is 0.
So let us say, see, VCC is, we saw, I think VCC can be much larger compared to VI.
Correct.
So maybe since VCC is fixed, we will change input only till VCC, no?
Sure.
Let us not go beyond VCC.
Yeah.
Right. So we will start from 0 and go to VCC.
Yeah.
Okay. When input is 0, okay, so let us let us make some assumptions.
Yeah.
We will say that beta is large.
Yeah.
Right. So we will make things easy by saying that we will neglect the base current.
Base current.
So which means that collector current is same as emitter current.
Yeah.
Easy, no?
Even otherwise, it was almost equal.
It was almost equal, right?
Mm.
So we will make this assumption,
Yeah.
right? And this is some IS or IE naught is what we used.
Yeah.
Maybe we'll use the same, no? Why change
that
it?
will be better. Yeah.
Why confuse?
Yeah.
And we also had this -1.
Ah.
We will neglect that also.
We'll neglect that.
Huh?
Yeah.
We will neglect that also. Well, technically we can't, but
at this region. But
at this region, but maybe once VB becomes large enough, we can neglect it.
yes.
Right? So I will put that in leave that in a different color. Okay. So when Vi is 0, Vi is directly VBE.
Correct.
So Vi is 1 minute. I think
That means there is no current initially.
correct. I'll just put this bracket.
Yeah.
So that it is not -1 standing by
Correct.
itself.
Correct.
Okay. So when VBE is 0, then it is 0.
Yeah.
This current is 0.
Yeah.
So if this current through RC is 0, then V0 is equal to VCC
Oh. Because there is no voltage drop in RC.
in RC. Correct. So we'll say this is some VCC. Okay. So input is 0, output is VCC.
VCC.
Clear. Okay.
Then we will increase slowly.
We'll increase slowly. So VBE, if you increase slowly, so VI will increase.
Yeah.
For very small values, no?
Yeah.
I think we saw till there is a knee point, no? This is like the diode characteristic.
Correct. Yeah.
Till you hit some
Very
0.65 volts, 0.7 volts,
Yeah.
you will not see a lot of current.
Correct.
You will see some very small current, which means
So till that it will be almost VCC
almost
itself.
VCC. Maybe one very light slope you might get.
Yeah.
Maybe I'll something like this.
Yeah.
I'll show something exaggerated. one.
Exaggerated.
In reality, you may not see such a strong slope,
Correct.
right? And then once it hits the knee point,
Ah.
lot of current can flow
Because then it is the active region.
in the forward active region.
Yes.
Correct. So in the forward active region, lot of current can flow. Small change in Vi will give you large change in current
Because it's exponential.
because it's exponential. Which means for this is basically Vi, no?
Then shall we write expression for V0 for that region?
For that region.
Since we know expression for current.
That is true. So in the right?
Yeah.
In the forward active region, we want to say that the output voltage
Yes.
will be
V0 minus.
VCC
yeah.
minus
Yeah. VCC minus.
ICRC.
Correct.
And this also we know, no? VCC minus RC times IE naught.
E power VB by VT. There we will neglect 1.
Yeah, in fact, instead of VB, we can write VI.
Yeah.
That is VI,
Yeah.
no?
Yeah.
We'll neglect that minus 1.
Correct.
Easy, right? So, which means
So this means as we increase Vi, output will decrease
output will decrease
because minus.
because of that minus, correct? Correct.
Exponentially it will decrease.
It is like decrease exponentially, correct?
Okay. Okay.
So, which means maybe something like this,
Yeah.
something like this?
Yeah. Yeah. Something
Maybe
like that.
Something like
Yeah.
that, right?
How long it will continue?
That's true. So, we need to find out that also.
Hmm.
Because if it really did that, it should, at some point in time, it will go somewhere, right?
Yeah.
Okay. So, most
Or
likely,
this forward active region.
it is valid only in the forward active region,
Correct. So that means VB or Vi should not cross VCC minus ICRC.
That is correct. That is correct. So Vi, so we said that V's collector base junction,
Is reverse bias.
yes, is reverse bias. Correct? That's
Yeah,
what we said.
yeah. So if Vi goes above VCC minus ICRC, then it will become forward bias.
That is correct. So if it goes above VCC minus ICRC, correct.
Yeah.
So till some point it will be like that. So
Correct,
maybe
correct.
I will show it somewhere here.
Yeah.
Shall I say?
Yeah.
So something like this.
Yeah.
Right? And then after that, what will happen?
It's forward.
The transistor is no longer in forward active region.
Correct.
It goes into that saturation region. We called it saturation.
Correct.
And the curve may continue in a slightly different fashion.
Yeah.
Maybe we don't need to worry about too much, but it will do something.
Yeah.
Right? Maybe it will do something here.
Yeah.
Right? We don't need to worry about it.
Yeah.
We can calculate the current, we can do all of that. Right? Okay. So this is good. So we have actually this. I have seen this before. Right?
So when the input increases, output decreases.
Output is decreasing. Exactly. So I think some of the students might be taking some other course where this might be useful, no?
In the digital.
In the digital, correct. Because I think
It's a kind of an inverter, although it's not a proper inverter.
it is not a perfect inverter, but when the input is low, the output is high. And when the output is high, when the input is high, output is low.
Yeah.
Right? So we are basically seeing an inverter, right? Or a very cheap inverter, shall we say, right? Or a easy inverter, right? Okay. So now it can, a modified version of this sometimes can be used as an inverter. You need to make some modifications in the circuit, right?
BJT MOSFETs are still BJT inverters are still used, no?
Yes, very common.
Because they are the fastest family.
They are the fastest family, and you actually get a lot of, our labs, we use only, BJT based inverters in all our circuits labs, and many of them.
Correct.
These are still very popular. Correct. It is called TTL, transistor logic, right? Correct.